everyone, this is Neha Sisodia, Assistant Professor at New LJ Institute of Engineering and Technology. We are going to discuss ER models in database management systems today. So ER model, that is called as Entity Relationship Model, are part of our first unit, data models. So the contents for today's discussion are introduction to entity, attributes, relationship, and then we will move on to ER diagrams and we'll see few cardinality constraints on designing ER diagram. Let's start with what is entity sets. So a database can be modeled as collection of entity sets. Now we also have relationship among those entities. So an entity is an object that do exist and is distinguishable from other objects as well. So for an example, specific person, a company, event, plans that are characterized by some features are called as entity. So as these entities are characterized by some features, they have attributes. So the feature that characterizes a particular entity are called as attributes. So for an example, people have name and address from where we can identify a particular person. So an entity set is a set of entities of same type that share some same kind of features or properties. So for an example, we have set of all persons, companies, trees, holidays, etc. Now let's see an entity set, customer and loan. So customer will have certain attributes like customer ID, customer name, customer's street, its city, and we have a loan where its number has to be mentioned and what is the amount of loan the customer has taken. So this is how the database will look like when we store all the information that is associated with the customer. It is the customer's ID, its customer's name, its street and its city. So similarly, we have the information about the loan, that is the loan number, and the amount of loan the customer has taken. Now we'll see what this attribute is. So attributes are actually represent the entire entity with some different values. So this is actually the descriptive property that is possessed by all the members of an entity set. So for an example, as we have seen in the previous one, the entity customer have customer ID, its name, its street and city. Similarly, the loan entity will have loan number and its amount. Now, as I said, the features will have some values, that is the attributes will have some value. Now we have to define the domain, that is the set of permitted values for each of the attribute that is allowed. There are few types of attributes like simple and composite attributes. There are single valued and multi-valued attributes, and we also have derived attributes. So a simple attribute will just have one value. The composite attribute will be comprises of more than one value, and the single valued and multi-valued attributes are actually if we have one single value for a particular attribute and multiple values for a particular attribute. For example, phone number, there may be more than one phone number associated with one person. But in composite attributes, we have like address, we have street number, city, flat number, etc. So in derived attributes, what happens is we can compute the value from other attributes that is already been in the database. So for an example, we have age and we have a date of birth. So the age can be derived from date of birth and the current date. So as I said, in composite attributes, suppose if we take the name as first name, middle name and last name that we usually do, it is a composite attribute. That means the one attribute have multiple values altogether. Similar is the way when we store an address, it is not a single value. We have multiple things to be included in order to complete the address. Now we'll see what is relationship sets. So a relationship actually is an association among several entities. So suppose I have a customer entity, I have a relationship set and I also have an account entity. So the customer will have some name. It will be a depositor to the account which is A102. So account entity will have an ID and the customer which is associated to that account either is going to deposit something or is going to withdraw something. For now, we have considered this relationship as depositor. So mathematically, how we can express this relation among the entities? Suppose we have more than two entities and from each of the entity set, then we have E1, E2, En that belongs to different entity set, capital E1, E2 and En, where we have this small E1, E2, En as relationship that defines the relation among two different entities. So for an example, as we have seen that this account and this customer has a relation of depositor. So this is what relationship set borrow is. Suppose a customer is going to set a loan account that is having the IDs like this, and we have several different kind of customers that can associate with this loan account. So similar kind of loan account can be given to multiple people. Now more on this relationship sets, an attribute can also be the property of relationship set. It is not like only the entities are defined by its attribute, but the relationships are also can be defined by an attribute. So for an instance, here we can see the depositor relationship among the customer and the account. We can set an entity set customer and account that have an attribute called as access date, because the depositor will access the account at some specific date and time. Now we'll see what is the degree of relationship set. So it actually refers to the number of entities involved in this relationship. So we have, if two entities that are participating into the relationship is called as binary or is called as of degree 2. So generally most of the relationship sets in the database systems are actually binary. So the relationship sets may involve more than two entities that are also called as complex relationship. More than binary means if only three entity sets are involved, that is called as ternary relationship, and beyond that we have a complex relationship with more than 3 degree that is not actually defined here. So the relationship between more than two entity sets are very rare, and most of the relationships that we used to consider in a database is binary. Now we'll see the mapping cardinalities. So what it expresses is the number of entities to which another entity can be associated with via that a particular relationship that has been set. So most of the that is most useful in describing binary relationship set, because one entity can be related in multiple times to the another entity sometimes. Okay, so for binary relationship set, the mapping cardinalities can be any of the following, that is one to one, one to many, many to one, and many to many. So what this one-to-one mapping cardinality is, one entity from one set can be associated with only one instance of the another entity set. One to many, that means one entity set can be associated with more than one instance of this particular entity set. And many to one means many of them has to be mapped to only one instance of an entity set. And many to many means many of the entity sets as E1 can be involved in the relationship with E2 instances. We'll see more on mapping cardinalities. So one to one will have one-to-one correspondence with each of the entity instance from A to B. So suppose we have A1, A2, A3, A4 as an instance for one entity set, that means every customer will have only one account, and every account has been associated with any of the customer that we have. For one to many customer, if we have, then we'll have one customer that can be associated with multiple accounts. Okay, so some elements in A may not be mapped to any of the other elements in the other set. So it may also happen in one to many, there are few customers that do not have any account. That is not practically feasible, but according to the mapping cardinality, we can have any of the entity instance in A can be left without any relationship to other set. Many to one relationship will have, we have multiple customers that will have only one account. So that can be happen in the basis of shared account when we have, or we have a shared account holding of more than two customers in case of bank loans or any other kind of loan accounts. Similarly, in many to many, we can have multiple customers that are associated with different kinds of accounts, and different kind of accounts can be associated with one type of customer. So there may also happen the same thing, that there are few instances they are left without any mapping to the other entity set. So let's see how this mapping cardinalities affect the ER design. So can we make the access date of a particular attribute of an account instead of relationship attribute if each of the account can have only one customer? So that is, the relationship from the customer to the account, or the account to the customer, is many to one, or it is equivalent to customer to account is one to many. That means only one customer can have multiple accounts, or in case the customer, the account to customer, we can have multiple accounts that are associated with only one customer. So in this case, you can see John is associated with more than one account in the bank, right? So in ER diagram, what happens is we represents the ER diagram with a rectangular, mostly diamond by for a relationship, lines for having the relationship set and that are associated, and what is the type of cardinality they have participated in. Then we have ellipse that represents the attributes, and we have underline that actually represents a key that we will study later. So the ER diagram is going to represent with a rectangular that is enclosed the entity set which relates with some another entity set, and there is a relationship that is represented by this diamond that is borrowed here, and we have some set of attributes like customer name, customer ID, customer street, customer city, loan number and amount. And there is something which is the identity of the entire information about the customer, that is called as a primary key attribute. So among all the attributes, we need to identify only one attribute that is responsible for the entire information about that particular entity. We'll see this later. Now this is the ER diagram which represents the composite, multi-valued and derived attributes. So actually the derived attribute is represented as the dashed ellipse. The multi-valued attributes in the ER diagram is represented as double ellipsed, and the composite attributes are described as the hierarchy of a particular composition. Suppose the name is splitted into first name, middle name and last name, then I can keep name as it is as a one attribute, and then I can split it over as we have to represent it as a composite attribute. Now the relationship set with the attribute, as we have seen, can have also have the attribute. So suppose I need to place access date as an attribute for a relationship set depositor, so I can make attribute as it is as we do it for entity in an ellipse, and then we can represent it by a line. Now what is the role of this entity set of relationship? Actually it need not to be distinct always. As you can see here, the employee will have an employee ID, will have an employee name, will have an telephone number. Now irrespective of what designation the person is holding, we also have to keep it as an employee. So it is not very much necessary always to keep this kind of relationships, but to make a clarification that there are few employees that are working under or working for a manager, but actually the manager is working for a company, so it is also an employee. So we need to specify the role as well sometimes. So we have manager and worker or employee. So altogether the manager is also an employee. So sometimes it is required to specify it explicitly, but it is always optional. Now as we have seen some cardinality constraint, we can express the cardinality constraint by a directed line or by an undirected line. So this directed line specifies one and the undirected line specifies many in the relationship between the entity sets. So one-to-one relationship will be represented as an arrow in both the sides to the entity set from the relationship. But one-to-many will have the many side where we have more than one loan account that can be associated with a customer. So at most one customer we are the borrower. The customer is associated with several including zero as well. So there are few customers that are left without loan account. So it is not necessary to take loan if you are a customer to a bank, right? So similarly, in many to one relationship at many side, we have to keep it like this, and at one side we have to keep this directed arrow. In many to many, we need not to specify any kind of arrow in any side, because it is many to many relationship. That is, many customers can have many loan accounts, and many loan accounts are associated with many kinds of customers. So this is what is called as participation of an entity set in the relationship. If we have a double line, that is called as total participation. If we have a single line, that is called as partial participation. So what this total participation is, actually total participation refers to every entity in the entity set, it actually participating in at least one relationship in the relationship set. So for an example, every loan account must have a customer associated with that. In partial participation, we have some entities that are not participated in the relationship set. So participation of a customer in the borrower is partial. So a customer may or may not have a borrower relationship, but if there is a loan account, that should be associated with some or the other customer. There are few alternative notations for cardinality limits as well. As we have seen, the zero asterisk that represents either there may not be any customer that is associated with that account, but in loan account, that is, every entity of this particular set has to be represented by at least one customer. So every loan account should be associated with one customer. So that is an alternative notation. So we have seen cardinality limits and its effects also in the ER diagram. In the next subsequent video, we are going to discuss about ER diagrams exhaustively, and the key points, what are some special relationship among ER diagrams and entity sets that we include in our ER diagram. Thanks for watching this video.